try and describe a complicated technical idea for a general audience without using any equations. So first I have to explain Hopfield nets, and I'm going to explain the version with binary neurons that have states of 1 or 0. So on the right there you'll see a little Hopfield net, and the most important thing is the neurons have symmetrically weighted connections between them. The global state of a whole network is called a configuration, just so we seem a bit like physics. And each configuration has a goodness. And the goodness of configuration is simply the sum over all pairs of units of neurons that are both on, of the weights between them. So those weights in red boxes, you add those up, and you get 4, hopefully. That's the goodness of that configuration of the network. And the energy is just minus the goodness. So these networks will settle to energy minima. The whole point of a Hopfield net is that each neuron can locally compute what it needs to do in order to reduce the energy, where energy is badness. So, if the total weighted input coming from other active neurons is positive, the neuron should turn on. If the total weighted input coming from other active neurons is negative, it should turn off. And if each neuron just keeps using that rule, and we pick them at random and keep applying that rule, we will eventually settle to an energy minimum. So the configuration on the right there is actually an energy minimum. It has an energy of -4, and if you take any neuron there, the ones that are on want to stay on, they get total positive input. The ones that are off want to stay off, they get total negative input. But it's not the only energy minimum. A Hopfield net can have many energy minima, and where it ends up depends on where you started, and also on the sequence of random decisions you make. The sequence of random decisions about which neuron to update. So that's a better energy minimum. Now we've turned on the triangle of units on the right, and that's got a goodness of 3 plus 3 minus 1 is 5, and so an energy of -5, that's a better minimum. Now, Hopfield proposed that a good way to use such networks is to make the energy minima correspond to memories. And then using that binary decision rule about whether you should turn a neuron on or off, that can clean up incomplete memories. So you start with a partial memory, and then you just keep applying this decision rule, and it will clean it up. So settling to energy minima, when they represent memories, is a way of having a content addressable memory. You can access an item in the memory by just turning on some of the item, and then using this rule, and it'll fill it out.